part 2 of the review packet. Once again, this review packet very closely models what you're going to see in the test, so please plan accordingly. We just finished solving equations. We're now going to expand and simplify the following expressions. Keep in mind, anytime you see an I, we're simplifying expressions. Once you get to this point, if you see an I squared, replace it with a -1. We're multiplying it by -1. X times x gives me x squared. X times -3i gives me -3xi. 3i times x gives me positive 3xi. And 3i times -3i gives me -9i squared. Make sure you make that I squared. These two values in the middle cancel out. What we're left with is x squared minus 9 times I squared. I squared is equal to -1. We're multiplying that by -9 times -1 becomes positive 9. X squared plus 9 is what that reduces to. Very nice. Next is x times x gives me x squared. X times 10i gives me 10xi. -10i times x gives me -10xi. And -10i times positive 10i gives me -100i squared. From here, simplify. Once again, this thing in the middle, these cross out. 10xi and -10xi cancel out. This is -100i squared. Once again, I squared is equal to -1. Replace it with the -1. This becomes x squared plus 100 because -100 times -1 gives me positive 100. You will see operations with the I in the test. Please make sure you understand how to do these. Next is write the following quadratic equations. Create one in vertex form if this is your vertex and this is your y-intercept. Now, make sure, come test time, that you guys have written down your forms. You want these easily accessible, right? You will be able to look at this. Like usually, a normal test, you will not be given this information, but you can have this information available for you. This is vertex form, and if you're given the vertex, plug those values in. We know this. So plug those values in. All of a sudden, it's just like working backwards with a graph. X minus 1 quantity squared plus 3. There's my vertex form. I need to solve for A, which you need to put a point in for x and y. Luckily, we're given that other point, 0, 5. So in order to solve for A, plug in 0 for x and 5 for y, just like that. What it reduces to, 5 is equivalent to A, which we're solving for, 0 minus 1 quantity squared plus 3. You subtract your 3 from both sides. To flip it over here, you get 2 equals A. 0 minus 1 is -1, and -1 squared. Make sure that's not an A squared. 2 is equal to -1 squared is 1. 1A is just A. A is equal to 2. So all you got to do is plug in that A right here. And that's my answer. 2 times x minus 1 quantity squared plus 3. Very nice. From there, write it in intercept form if the x-intercepts are -1 and 6. So my p value is -1, my q value is 6. When you're creating intercept form, you need to solve for these three variables, x minus p times x minus q. A is what we'll be solving for. Your intercepts go right here. And make sure you're subtracting them. What that relates to, A times x minus a -1, which is going to turn to plus, and x minus 6. Y equals A times x plus 1, x minus 6. We're going to solve for A with this point, 1, -10. Every time you see an x, you plug in 1, and every time you see a y, you plug in -10. What that relates to is -10 equals A times x plus 1, which is going to be 1 plus 1. We're plugging in that point. X minus 6, which turns into 1 minus 6. Reduce. 1 plus 1 is 2. 1 minus 6 is negative 5. 2 times negative 5 is negative 10a. If negative 10 equals negative 10a, divide both sides by negative 10, a equals 1. You take that value, you plug it in right here. Which you could write the 1, you could don't write the 1. But since 1 multiplies every number can technically be multiplied by 1, that's basically your answer. Boom. We move on. In intercept form, graph the graph to the right. So once again, intercept form, this is just like the ones we just did. Except we're shown the intercepts instead of told what they are. My intercepts are 1 and negative 3, so plug in those values. X minus 1, x minus the negative 3 becomes positive. From this point, we have to use a point that's also in the graph. You could use it. You could use your vertex. You could use this point. I'm going to use 0, 3 because using 0 is very fun. It wipes away your other values. So this 3 is my y value. That goes right there. My 0 is my x value. That goes right there. You plug it in. 3 is equivalent to a 0 minus 1 times 0 plus 3. 0 minus 1 is negative 1. 0 plus 3 is 3. 3 times negative 1 times a is negative 3a. When you divide both sides by negative 3, you get a is equal to negative 1. And that value goes right here. And this is my quadratic. Negative 1 times x minus 1 times x plus 3. Now these determine the number of types of solutions for each quadratic. This would be more of a extra credit portion. We haven't done too much over this, but this is called the discriminant. The value underneath your square root symbol in the quadratic formula is called the discriminant, right? You guys remember b squared minus 4ac, right? X equals opposite of b plus or minus the square root of b squared minus 4ac. This is your discriminant. B squared minus 4ac. Not the whole formula, just what's underneath the square root. And what's underneath the square root tells us how many solutions we're going to have. And I'll show you why that's so. Because if you were to take b squared minus 4ac, for this example, your a value is 3, b value is negative 2, c value is negative 5, b squared is negative 2 squared minus 4 times 3 times negative 5. Negative 2 squared is 4 minus 4. 4 times 3 is 12 times 5 is 60. And since there's two subtraction signs, it turns into a plus plus. You're adding 60. This is going to be 64. Since 64 is a positive number, you can take the square root of 64. It's going to give you 8. You're going to have two solutions, two real solutions. Right? If you're square rooting a positive number, you will have two real solutions for you. If this number was negative, you would have two imaginary solutions or no solutions, if you will. You would have imaginary solutions. That's why they do it. With discriminant, when it's positive, any number, 5, 120, 64, like we just did 1, you have two real solutions. When your discriminant is negative, you have 0 real solutions, or two imaginary solutions actually, but 0 solutions. And when your discriminant is 0, you actually have just one solution. Because the square root of 0 is 0. When you add or subtract that, it stays the same. This next one, we're going to perform the same discriminant operation. Once again, we haven't gone over this in class very often, so you will see understanding this is very important for the test, but you won't be tested directly on these kind of values, these questions. Just doing b squared minus 4ac. 4 squared minus 4ac. 16 minus 4 times 2 is 8. 8 times 7 is 56. This is going to be a negative 40, which means there's 2 imaginary solutions or 0 real solutions. Boom. And that is the entire packet. Thank you.